Welcome to True Projects. In this video, we are going to explain about a hybrid fault-tolerant routing based on Gaussian network for wireless sensor network. Introduction. Wireless sensor networks are self-organizing networks that can sense the environment and by finding neighbors can send that sensed data to the centralized server or base station. These networks don't need any human monitoring, but they frequently fail due to weather conditions, and failed nodes won't participate in transmission, disrupting service. Many forms of cluster-based routing have been developed to address the problems. However, none of these existing cluster-based routing systems are efficient fault-tolerant. Instead, each network has a high-power cluster head that receives data from the nearest node and sends it to the base station. Objective. The project's goal is to suggest a hybrid fault-tolerant routing algorithm for wireless sensor network based on Gaussian network in order to promote fault tolerance, boost data dependability, and use less energy. The proposed protocol makes advantage of a hierarchical topology to cluster sensor nodes and label them as Gaussian integers. The network region is partitioned into tiny square grid with a Gaussian integer serving as the cluster head of each grid. A Gaussian network is built by connecting these cluster heads together. High data dependability and energy efficiency are the goal of the suggested protocol in wireless sensor network. The result of the experiments demonstrate that the proposed protocol performs better in terms of energy usage and data dependability than alternative methods. Requirements. To implement this project, we have two kinds of requirements: hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Generate Grid-based Gaussian network. Using this module, we will generate random nodes network and each node will be placed in grid by checking their distances. And the second module is Cluster Formation. Using this module, we will evaluate each grid and then choose active node with high available energy and having close distance to base station and covering maximum common nodes, and each node updated stable about cluster head and neighbor nodes. The third module is fault-tolerant routing. Using this module, we will transfer data by selecting source node and source will choose nearest cluster head, primary routing node and alternate routing node from table and start sending data. And the fourth module is energy consumption graph. Using this module, we will plot residual or available energy between propose and leach technique. Proposed technique will not go for discovery again and again, so its energy will be saved. But leach, inspect routing table and update discovery again and again, so its energy consumption will be more. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the main code file. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. A graphical user interface will pop up. So this is the graphical user interface. Click on Generate Grid-based Gaussian network to generate Gaussian network. So here we can see the red color nodes are the common WSN nodes and the blue color is the base station. Now click on Cluster Formation button to get cluster head selected nodes, and all nodes will be in the grid. All big oval will be considered as grid and the green color will be considered as the cluster head selected nodes, and all nodes will be in the grid. Now select a node ID from the node drop down box and click on fault tolerant routing. So here we can see that node 5. So this line represents the transmission of the data from the source node to the base station. So the source node is node 5 and this is the base station. Blue color represents the base station. So the source node will select its nearest neighbor and transfer the data to the nearest neighbor. So the nearest neighbor to the node 5 is node 4. So the data is transferred from node 5 to the node 4, and node 4 will transfer the data to its nearest neighbor. So the nearest neighbor to the node 4 is CH2, which is the head node. So node 4 will transfer the data to the head node, that is CH2, and CH2 will transfer the data to the node 2, and from node 2 the data will be transferred to base station. So in this way the data is transferred from source node to the base station. Now we will select another node ID from the node ID drop down box, say 4, and click on fault tolerant routing. So this is the way. So node 4 is the source node and CH110 is the head node and blue is the base station. So from node 4 it is going to the node 1, and from node 1 it is going to CH110, and from CH1 it is selecting its nearest neighbor, that is node 17, and from node 17 it is selecting its nearest neighbor, that is node 13, and from node 13 the data is being transferred to the base station. So in this way the data is transferred from the source node to the base station. Now click on energy consumption graph. So this is the energy consumption graph. On the x-axis we have number of nodes, and on the y-axis we have residual or available graph, and the green color line represents the existing leach energy and the blue color represents the proposed FCGW energy. So we can see blue line is having high available energy compared to leach, so it's consuming less energy. Exit simulation. The final conclusion of the project is the project's findings show that the hybrid fault-tolerant routing protocol for wireless sensor networks based on the Gaussian network has enhanced fault tolerance through symmetric links and multipath routing. The complexity of routing algorithms is decreased, as well as the cost of routing and multipath routing maintenance. By using Gaussian integers to represent cluster heads, it is significantly difficult that increases packet delay to connect long distance sensors nodes as a Gaussian network in wireless environment. The features of the Gaussian network and its Hamiltonian cycles will be used by us to address broadcast concern in wireless sensor network in upcoming work.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.